Yes, dear student. Now this program I am going to explain about the conversion of hexa value into the decimal value. Here the program I already written in the document file. So just I am copy and pasting the program in the editor window of the Key software. Okay. Now here I took 0xcf as a hexadecimal value that I am going to declare as a variable as an unsigned character, and I need to convert this 0xcf into hexadecimal into decimal value. Again I am going to declare as a decimal variable using a unsigned character data type here. Okay, so let us explain how this function works by converting hexadecimal value into a decimal value. After return the program into the editor file of my Keel software, you have to click on save here and build the application file. Okay, when in the application file or program file, I don't have any syntax error or logical error, so I got as a zero error here. After getting zero error by build option, now I need to debug this file. Click on debug option. Click OK. Okay. So let me close this window, pop-up window. Okay. Here I am going to convert hexadecimal value to decimal value. The conversion of hexa to decimal I am going to store in the ports of port 0, port 1 and port 2 of the 8051 microcontroller. In order to show the converted decimal value, I am going to store in the pins of the port 0, port 1 and port 2. I need to check whether the hexadecimal is converted into decimal value or not. In order to check that, I have to go to the peripherals, click on IO ports, select port 0, it will pop up port 0 window. Again go to peripheral, go to IO port, click on port 1, again it will pop up port 1 window. Again go to peripheral, go to IO port and select port 2 option. Port 2 pop-up window here. Why I choose this pop-up window of port 0, port 1 and port 2 means I used port 0, port 1 and port 2 in my program to store the decimal value of the pins of this respective pins of the ports. Okay, so that is what I need to verify the outputs in in the pins of all the respective pins of the port 0, port 1 and port 2 here. Okay, here I am going to perform the division operation. In the division operation, the A value is having hexa value called 0xcf. After performing A divided by 10, this 10 is nothing but decimal value. Okay, I am performing A by 10. After performing division operation, the quotient value it is going to store into the decimal variable. The quotient it is stored into decimal variable. Remainder value it is going to store into the B register. See here, initially before execution this instruction, the register accumulator A value is 0 and B register value is 0 here. Let me click on to the step option in the Key software. Now it becomes A is 0x14, nothing but the accumulator register. It will store the value of remainder by remainder value which is performed in the division operator, and the B register it is going to store the quotient value as a 7. The sorry the A register The A register it will store the quotient, okay, and B register it will store the remainder value, okay. After performing the division operation, the register accumulator, we call that as a register A, or accumulator, it will store the quotient value, and remainder value it will store in the B register. The remainder value stored in the B register I need to pass into the port 0. What is the value of B register? 0x07. Before execution this instruction, by default the pins of the port 0 is 0xFF, nothing but all the pins of the port value is high by indicating tick mark on the respective pins of the port 0. Okay, after execution the value of the port, the value of the register B I am going to store into the port 0. Let me execute. It convert into 0xFF into 0x07, nothing but 0000. This is 4 bits of 0 and 0111. Wherever tick mark is there, it represents logical high value, okay. And in the decimal value it is going to store into the quotient as a 1 4, that is in the hexa value. Again I am going to perform the division operation by 10 value, okay, by executing this instruction called step option in the key window. What is the value of the accumulator? The value of the accumulator is quotient. It is nothing but 2. The quotient value it is going to store into the A register, and remainder value it is going to store into the B register. Okay. After executing B1 is equal to B, the value of B register is 0 because the B register contains remainder value. By executing this, all the pins of the port 1 is converted into 0xFF into 0x00. Okay, let me click on the step option in the key. It convert into 0xFF into 0x00. Okay, because the register B has a 0 value, nothing but remainder value of the division operator. Now, finally, again the decimal is nothing but it contains the quotient value. That quotient value is stored in the register A, nothing but accumulator. The final value of quotient it is going to store into the port 2. Before execution of this instruction, port 2 is equal to deci. Before value by default it has 0xFF. After execution it is instruction, the value it is changed to 0x02. Let me click on the step option in the key software. It becomes 0000010. Tick mark indicates logic high operation. So the conversion of 0xCF hexadecimal value which is equal to 207, where port 2 contains MSB and port 0 contains LSB values. Okay, so after that the program becomes halt by writing the instruction called while of 1 here. If I click on step, the program becomes infinite loop condition. So here my program becomes halt. So this is the value of CXF, sorry, 0xCF hexadecimal value into 207 in the decimal value. Port 2 contains 2, port 1 contains 0, and port 7 contains 7. Nothing but the equivalent value of 0xCF is equal to 207 in the decimal. Thank you.